Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from three-dimensional geometry, right? And here we are going to discuss the concept of image of a point with respect to some given plane, right? So here what we are going to discuss is that we are given a point, right? See, here we are given a point 7 comma 14 comma 5, and we have to find the reflection of this point with respect to this plane, right? So here we are given the equation of the plane as 2x plus 4y minus z is equal to 2, and this is the Cartesian equation of the plane, right? And we have to find the image of this point with respect to this plane, right? So let us start, and let us first draw a rough diagram of this problem, right? See, here we have a plane, right? This is the plane P, and here we can write P, and the equation of the plane P is given as 2x plus 4y minus z. Minus 2 is equal to 0. So we can take this 2 to the left hand side, and this equation is of the form ax plus by plus cz plus d is equal to 0, right? Okay, so this is about the plane, right? And now we are given a point, say this point is A, right? And here the coordinates of this point A are 7 comma 14 comma 5, right? And we have to find the reflection of this point A, or the image of this point A with respect to this plane P, right? So here this plane P will act as a mirror, right? So with this mirror we have to find the image of this point A, right? So let us call the image as B, right? So let us take B as the image of this point A, and let us call the coordinates of this point B as alpha, beta and gamma, right? And here in this problem we have to find the values of alpha, beta and gamma, and here we'll utilize the concept of the general point lying on a given line, right? So here let us join this point A and B. So here we have the line AB, right? Okay, and this line AB, it cuts this plane P at say some point M, right? And here we'll first find out the coordinates of this point M, and we know that the point A and B are equidistant from this plane P, because this point B is the image of this point A, right? So AM is equal to MB, right? So the second concept which will be utilized here is that the midpoint formula, because M is the midpoint of AB, right? So now let us first write the equation of this line AB, right? So equation of this line AB is given as x minus x1 over say A1, y minus y1 over B1, and z minus z1 over C1, right? So here this line AB passes through this point 7 comma 14 comma 5, right? So we can take this point as x1, y1 and z1, right? So we can now write x minus 7 over A1, y minus 14 over B1, and z minus 5 over C1, right? Okay, so here A1, B1 and C1 are the direction ratios of this line AB, right? And we do not know the direction ratios of this line AB, right? So for this, what we will do, we'll utilize the concept of normal vector to this plane P, right? See, the normal vector to this plane P is like this, right? This is the normal vector to this plane P, and we see that this normal vector is perpendicular to this plane P, right? And this line AB is also perpendicular to this plane P, and therefore we can say that this vector n is parallel to this line AB, right? Okay, so the direction ratios of this normal vector can be obtained by the coefficients of x, y, and z, right? So the direction ratios of the normal vector to the plane P are given by 2, 4, -1. Here we have 2, here we have 4, and here we have -1, right? Because the direction ratios of the normal vector are given by the coefficients of x, y, and z in the equation of the plane, right? So once we have obtained the direction ratios of this normal vector, we know that if two vectors are parallel, then their direction ratios are either equal or proportional, right? So the direction ratios of the line are A1, B1, C1. So the direction ratios of this line AB can be taken as 2, 4, -1. Right? So A1 can be taken as 2, B1 can be taken as 4, and C1 can be taken as -1, right? Because A1, B1, C1 are proportional to 2, 4, and -1, right? So now the equation of the line AB is given by x minus 7 over 2. Here we have 2, then we have y minus 14 over 4, and then we have z minus 5 over -1, right? So this is the equation of this line AB, right? So always remember, whenever we have to find the image of a point with respect to some given plane, we have to first obtain the equation of the line AB, right? Okay, so now let us apply the concept of a general point lying on a line, right? So here what we will do, we'll introduce a parameter lambda, right? So lambda is some scalar, and this lambda is introduced to get the coordinates of the general point lying on this line AB, right? So now we can write x minus 7 over 2 is equal to lambda, y minus 14 over 4 is equal to lambda, and we can write z minus 5 over -1 is equal to lambda, right? So here we have written three separate equations using this parameter lambda, right? So from here we can get x is equal to 2 lambda plus 7, then y is 4 lambda plus 14, and z is minus lambda plus 5, right? So x, y, z depends on the parameter lambda, right? So for certain values of lambda, we have this condition, that is we have to find the image of this point with respect to this plane, right? So now the coordinates are given as 2 lambda plus 7, 4 lambda plus 14, and minus lambda plus 5, right? So this is the general coordinate of any point lying on this line AB. And see, here this point M lies on this line AB. So we can take the coordinates of M as this coordinate, right? And moreover, this point M, it lies at the same time on the line as well as on the plane, right? Because M is the midpoint of AB, and M lies on AB as well as on the plane P, right? So now this concept will be used to find out the value of lambda, right? So we'll substitute this coordinate in the equation of the plane, which is equation number 1, right? So now this point M satisfies the equation of the plane P, right? So we can now write 2 times. For x we have 2 lambda plus 7, and then we have plus 4. Y is 4 lambda plus 14, and then we have minus z. Z is minus lambda plus 5, and minus 2 is equal to 0, right? Okay, now this is a linear equation in lambda, right? And we can solve it. So this is 4 lambda, this is 14, this is 16 lambda, this is 56, and this is plus lambda minus 5, and minus 2 is equal to 0, right? So this is 16 plus 4, 20, plus lambda, that is 21 lambda, and here 56 plus 14 is 70, and 70 minus 7 is 63, right? And here we have 21 lambda is equal to minus 63. So lambda is minus 63 over 21, that is minus 3, right? So the value of lambda is minus 3, right? Okay, so once we have obtained the equation of lambda, we can substitute it here, right, to get the coordinates of point M. So the coordinates of point M can now be written as 2 lambda plus 7. So lambda is minus 3 here, 2 minus 3 plus 7. Then we have 4 times minus 3 plus 14. Then we have minus 3 plus 5, right? So this is minus 6 plus 7, that is 1. And here we have minus 12 plus 14, that is 2. And here we have 5 plus 3, 8, right? So we have now obtained the coordinates of this point M, and the coordinates are 1, 2, 8, right? And M is also the foot of the perpendicular, right? So here because AB is perpendicular to this plane P, and M is the foot of the perpendicular, right? So now we have the situation. See, here we have the line AB. We are redrawing it. Here we have 7, 14, 5. This is M, midpoint 1, 2, 8. And here we have B, alpha, beta, and gamma, which is the image of this point A, right? And since M is situated at the midpoint of AB, so by the midpoint formula, we can have x is equal to x1 plus x2 over 2, y is y1 plus y2 over 2, and z is z1 plus z2 over 2, right? And here this point is x1, y1, z1. This point is x2, y2, z2, and this point is x, y, and z, right? So now we can utilize these three equations. See, x is here 1, so we have 1 is equal to x1 plus x2, so we have 7 plus alpha over 2. Then we have the second equation, y is 2, and we have 14 plus beta, because y1 and y2 are 14 and beta, and here we have 2. And then we have the third equation, that is z is 8, so we have 8 is equal to z1 is 5, and here we have gamma over 2, right? So now we can solve these three equations here. So we can now write alpha plus 7 is equal to 2, and 14 plus beta is equal to 4, and 5 plus gamma is equal to 16, right? So from here alpha is 2 minus 7, beta is 4 minus 14, and gamma is 16 minus 5, right? So 2 minus 7 is minus 5, 4 minus 14 is minus 10, and 16 minus 5 is 11, right? So viewers, this is how we can obtain the coordinates of this point B, which is the image of this point A, right? So the coordinates of the image of this point A are given by minus 5, minus 10 and 11, right? And this is how we can solve this problem.